Good evening, and thanks for joining us. Tonight we'll be talking about math and a big game that may be coming up real soon, and how your students can use math and algebra and geometry and maybe even calculus and make connections with some of those things that happen in that big game. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited about our panelists that have joined us tonight. Tonight we're lucky enough to be joined by 3 panelists: Becky Byer, Becky Underwood, and Steve Phelps. Becky Byer is a nationally board-certified teacher who teaches grades 9 through 12. Her current classes at Kelly Walsh High School include Algebra 2 and AP Statistics, as well as computer programming. Becky has also taught pre-algebra and Algebra 1. Becky has a bachelor's degree in mathematics education from Black Hills State University and a master's in mathematics education from Montana State University. Becky, thanks so much for joining us tonight.
It's great to be here.
And Becky Underwood is in her 31st year of teaching high school math and computer science in Casper, Wyoming. Becky Underwood and Becky Byer both teach in the same school, and they're also sitting right next to each other tonight. So we have dueling Beckys. Becky Underwood has taught everything from foundations math to AP calculus and AP computer science. In 2011, Becky was invited to be part of a T-Cubed teacher leader cadre focused on training with TI-Nspire technology, which includes the TI-Nspire Navigator system, and this totally changed her teaching for the better. Becky's been a T-Cubed regional instructor since 2012. Becky Underwood, thanks so much for being with us tonight.
I'm glad to be here.
And last but not least, Steve, a longtime geometry teacher, currently teaches AP Statistics, and Computer Science. Steve is a T-Cubed national instructor and co-author of the Advanced Quantitative Reasoning, Mathematics for the World Around Us, presenting quantitative literacy, statistics, and modeling as alternatives to the traditional high school senior math course. Steve, thanks so much for being with us tonight.
Thanks, I'm excited to be here.
We're expecting a large crowd, so your audio is muted. Feel free at any time to send questions to the Beckys or Steve using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. A few reminders: this session is being recorded, and we'll provide a link to the event certificate of attendance at the conclusion of the webinar. We're also going to be providing a link to the documents that are being used tonight, also at the conclusion of the webinar. We'd love for you to follow along with the recording once that's available in a couple days. That way you can really go at your own pace and pause and rewind the recording as necessary. We hope you don't have any audio issues, but in the event that you do, find your name in the participant window. In that same window, you'll find a phone icon, and by clicking on that icon, you'll be given information to call in using your phone, which should alleviate any further audio issues. At this point, Becky Underwood is going to discuss our agenda.
All right, tonight what we are going to do is, first off, Becky Byer is going to lead you through explanation to help you determine who might win that big game. And then Steve is going to help you come up with a 3D model of a football. And then at the end, I am going to go through some information about the 30-second commercial and the cost of those and look at the data for those. And make sure, notice it says that you might win a registration for 2 to the 2018 T-Cubed International Conference. And if you've never attended one of those, you absolutely would be, it's wonderful to get to do that. So hopefully, good luck to at least one of you to win 2 registrations.
Thanks so much, Becky. And Steve is going to discuss our expected outcomes.
Thanks, Mike. So by the end of this session, you'll have explored some data using box plots, histograms, and normal distribution calculations, and you will also have investigated and modeled data using multiple functions while discussing lines of best fit and things like that.
Thanks, Steve. Becky Byer, it's all yours. Feel free to share your screen.
All right, everyone. So the first thing we're going to do tonight is just take a look at some data. Usually I have my students go select their favorite team and take a look at some of the completed passing yards from their favorite quarterback. So I have two different teams here that we're going to take a look at tonight. So one thing I want you to think about, so completed passing yards, if you take all the data for, let's say, the last 2 years, what do you suppose it might look like for a quarterback? So I'm going to graph the first one. There's a little histogram data. What might you be able to notice about the completed passing yards? What would be some things you might have those students discuss looking at just the first team there? I'll pause to give you a few seconds there if you want to go ahead and respond in the chat window. What are some questions or some aha moments you might make with that data? Well, I've lost my chat window.
And Becky, while people are thinking and maybe typing and responding, I just want to add that whenever they're using that chat window, there's a few options as far as who they send their chats to, and the best send to option is all participants. That way, both Becky's and Steve and myself will see it. So all participants is preferred compared to all attendees.
All right, so I have seen in the chat window there's some great questions in there. What can you say about the data? Some people are talking about mean, median, and mode. Are there some outliers? I see approximately symmetrical. So now my question is going to be, does that hold for both quarterbacks? So let's go back to our data, and let's turn off our current team and go to another team and take a look at that histogram. Go back to that histogram real quick. Maybe I didn't turn it on. I did not. It's still turned off. Okay. So if I turn it back on, all right, so now thinking about the previous quarterback compared to the new quarterback, what are some things that you might notice about the data or the students might notice? All right, so we're talking about skewed right on this one. The other one people said looks maybe approximately normal, spell shape. So now I might want to ask my students, could they compare the two side by side? So let's go back to our graph. Let's turn back on the first team. But maybe instead, let's go take a look at a box whisker plot. And let's graph those. Oh, someone just asked, they're not sure what's being graphed. It's the completed passing yards for each quarterback for the last 2 years. So we went online and found a website that would give each game's completed passing yards. So you have about 30 data points for each player if you look over the last 2 years. So now you have quarterback number 1 and their completed passing yards for the past 2 years. And you have the second quarterback. So if you're comparing the two, what are some comparisons students might make about that completed passing yard? All right. So I'm seeing some great discussion. A lot of people are talking about they want quarterback number 2. So now here's my next question to pose. Does this data provide us some good evidence that maybe the green quarterback is going to be more successful in an upcoming game against the blue team? can we use that data to support that claim? Why or why not? Oh, someone wants to take a look at the defense. So these are all some great discussions that my students usually come up. Usually I have them pick some of their favorite teams and kind of compare the quarterbacks. And they're making the exact same conclusions I've seen in the chat window. Some people have noticed that the green quarterback, the upper 3 quartiles, happen to be approximately equivalent or higher than the median for the first quarterback. Some people said we're not taking into account defense. Some of my students will talk about where we're looking at passing yards. Not every team relies heavy on passing yards, but it's a great activity to get your students to start thinking about the shape of data, what can you say about data, and how can you use that to make some predictions or maybe not make some predictions. So for the part 2 for the exploration tonight, I want to go back. Somebody had mentioned that the blue one looked like it might be approximately normal. And so with my AP Stat kids and actually my Algebra 2 Honors kids, we take it a step further, and you might have them either do a dot plot by hand, or I'm going to switch to an Nspire for a second and just do a real quick dot plot for one of those teams. And we're going to do a little investigation now to see, is the quarterback's completed passing yard maybe approximately normal? So the exact same data we've been playing with. So the first thing I have the kids either do on their calculator or by hand is to plot the mean for the first set of data points. And then I will have them calculate the standard deviation. You could do that up above, or you could do it right here like I'm going to do. And so then I just usually have those kids store that as a variable because I don't want to have to retype that standard deviation of the sample over and over again. But I do want them to go back to the graph, and I want them to plot that value. And I say, what happens if I take the mean and I go out 1 standard deviation? No solutions found. That's perfect. Or we'll just retype that. Well, a lot of values. Try this again. So the mean for the blue was, oh, I think I just typed in blue for those of you at home. You did. I did. Thanks, Beck. Plus 1 standard deviation. And then if I back up and I say, let's plot the mean for the blue team minus 1 standard deviation. If it's approximately normal, what % of my data points should be in between 1 standard deviation there? 68% as I'm seeing in the chat window. So if you count, there's 29 dots on the screen because I counted my data points before. And there's only 1, 2, 3, 4, 5, 6 down here, 7, 8, 9, 10 above. So 19 out of my 29 data points are inside 1 standard deviation, and that's about 66%. So I don't know about you guys, I think that's pretty close to that 68% empirical rule there. 1 point, give or take, would be outside. So then we do the same thing, but we're going to go out 2 standard deviations. If I go at 2 standard deviations, what % of my data points should be within 2 standard deviations? And I'm seeing 95 in the window. Well, for this particular team, it happens to be 100%. But again, I think that's pretty close, and we're only dealing with 30 data points. Some of my students have gone back before, and they've actually collected the last 3 years. And then they've had some great discussions as to how independent is it if you're comparing data from 3 years ago versus the 3 current years. But it kind of followed that 68-95% rule. If we change it and we go look at the green team, and let's take out our line here, and take out our line here. If I do the exact same thing, if I plot the mean for the green team, and then I plot the mean for the green team, if I didn't create a variable and have to type the whole thing out. And then I go back. And I did a plus, not a minus. Okay, so this one actually happens to have 28 data points. Quarterback must have been injured for one of the games, so there's one less point to use there. When I have this projected on the screen, I usually have the kids decide, does this point in or out of the mean, or actually we can hover over and see this one's out. Or sorry, within that 1 standard deviation. So there's 4 points that are out of the standard deviation. There's another 5 up there, so 9 out of 28 are not within 1 standard deviation. Again, it's close to that 68% rule. If we went out 2 standard deviations, we might be closer to that 95% rule on this guy. I think this one actually was out when I did it earlier today. So this one, you actually are going to be closer to that 95% rule if you go up 2 standard deviations. So 28 out of 29 of my data points. Pretty close to 95%. So this is one way I've actually used this data with my students in the past to kind of talk a little bit about approximately normal. My students in the past have really challenged me. They said there's no way that the empirical rule actually applies to real life. So this one's actually fun if you let them pick any professional, or some of them have even gone and picked maybe different college quarterbacks and looked at their data. Usually you want to get at least 30 data points just so you can have enough data to kind of start seeing, you know, those outliers are going to start kind of leveling out. I don't know, what do you guys think? Can you think of anything else you might do with this data with your students? Well, okay. If there aren't any other ideas, I think at this point I'm going to go ahead and pass the ball over to Steve. So let me see if I can stop sharing and pass it over.
Oh man, now I'm the presenter.
Yep, Steve, you're up.
Let's see what happens. See what happens. So so here's my goal. Here's my goal, and I'm curious about this. So I'm going to use the 3D graphing capabilities of the Nspire. So if you are an Nspire user, yes or no? Have you ever used the 3D graphing capability on the Nspire? So if you're an Nspire user, yes or no? Oh my gosh.
They're almost all no so far.
I saw a yes. I did see a yes, but essentially that means everyone's a no. For statistics reasoning. So here's my goal. Thanks for participating in the little survey. So again, in 10 minutes tonight, I want to show you how to make a 3D football. If you have questions, you can certainly hit me up on Twitter, or email me. And so here's what this is like our final product, except it may not be brown, and we may not have time to change the color, but we'll see. But it's kind of cool. And so, you know, if we let me stop this, and if I look down the x-axis, got all these concentric circles, and it turns out if I look down the y-axis by pressing the Y button on my keypad, these little curved lines from tip to tip are actually arcs of circles that have been rotated around the x-axis. So let's talk about this on getting this football made. And we'll start in a graphing plane, in a regular graphing plane. And as it turns out, the football is kind of, the shape of the football is kind of a region formed by the intersection of two circles. So what I'm going to do is I'm going to take go down here to my geometry tools and go to my shapes and go to my circles. And I'm going to place the center of my circle somewhere down here on the y-axis. And I'll drag that puppy over here to somewhere on the x-axis, kind of in between the tick marks so it doesn't stick to the tick marks. And then I'm going to put that tool away by pressing escape because I don't want to make circles everywhere. And then I'm going to go back and I'm going to reflect this circle over the x-axis. So I'll go back down to geometry and I'll go down to the transformations and I'll select number 2 for my reflections. And I'll just click on the circle and click on the x-axis. And then before I do anything else, I'm going to press escape to put that tool away, because if I don't put that tool away, I'll be reflecting everything on my screen. I don't want to do that. And so this shape here is kind of the shape of a football. And so let me see if I can insert an image of a football that does not have any type of logo on it or any type of identifying features. Bam, that's a nice, plain, kind of a vanilla type of a football. And so let me see if I can drag, maybe I can drag the center of that puppy there, and I can grab that point and put that out there in the tip, and then see if I can drag the centers. So I've kind of got this matched up, kind of close. Not too bad. It's not too bad, but that's kind of the general shape of that football that's formed at the intersection of the two circles. And so what I'd like to do is I'm going to find the circle that goes over the top. I'm going to find the equation of that circle by using the coordinates and equations. So there's the equation of that circle there. And I want to find the coordinates of this point out here on the right-hand side, because I'll need that in my 3D graphing window. And so the coordinates of that point, among friends, we'll just call that 9. And equation of the circle over the top, and the intersection point of that circle with the x-axis, which will give us the tips of the football. So what I need to do next is I want to rewrite this equation in function notation. So I'm going to do it right here on this graph. And so what I'm going to do is I'm going to start with the 10.14 squared, and I'm going to subtract off the x squared, and then I will go back and I'll put this in a square root. And then I want to subtract off the 4.72. Oops, it'd help if I put in a minus. And so there is the, I can probably hide that one. So that is the, I guess the top half of the circle, and that's the equation that I will use to help me form the shape of my football. So if you haven't used a 3D graphing, here's how it works. It's easy to do. I added a graph page earlier. And so on my graph page, if I go to the menu options, and then under the view menu option, which is number 2, the third thing down is 3D graphing. And we can change that to 3D graphing. And we kind of have this 3D box that I can rotate and manipulate. The next thing we need to do is, right now this is in function notation. I need to change the graph entry edit to parametric equation. So I'll go back to my menu, and I'll go to number 3, the 3D graph entry edit, and I'll select parametrics. And then I guess before I go jumping into the parametrics, if we look back on our graphing screen before, The football, the tips of the football are about at -10 and +10, or actually about -9 and +9. And so if I look at my box, the x-axis on my little clipping box only goes from -5 to +5. So I need to change the range settings on my box. And so I go back under the View menu, and the fourth option is Range and Zoom. And I select the range settings. And I want to change all of my X, mins, and maxes to -10. That'll make my football fit well, or not -10. I'll either make them go -10 or +10. -10 on the Y min, +10 on the Y max, and -10 on the Z min, and +10 on the Z max. And the box doesn't change its size necessarily. What it does, it just changes the scale. Now, to graph a football or to rotate a circle around the x-axis, these three equations are the equations that I will use to create this surface of revolution, essentially, which will form the football. F1 of t is already saved. That's one of the equation I graphed on the previous page. And we'll talk kind of through this if we have a chance. But let me go back to my graphing page, and let me pull the graphing window back. So I'll go Control-G. And so I'm going to type a t for the x-coordinate. And then if I go to YP1, I will type in F1 of t. That's where my equation of that top half of the circle is. And I'll go times cosine of u. Now, this is a surface. It's a two-dimensional shape, so there needs to be two variables to control it. So t is one variable and u is the other. Now we'll go F1 of t again, times sine of u. And then before I go crazy and hitting the enter button, I need to make sure that my t limits and u limits are set up properly. So over on the right-hand side of my screen where those little three dots are, I click on that puppy, and this is where my parameters are located. So I want my t min and my t max, I want them set up to be the coordinates of the tips of the football. So one of them was roughly at around -9. And then the maximum would be at around +9. And then the U min and U max are the angle that that circle is rotated. So right now, if I kept it at 0 and pi, I would only graph half of a football. So I'm going to change the pi to 2 pi, and then I'll click OK. And then if I go back up into the little equation area and press enter, and it's blue, but that's okay. That's okay, but if, I can zoom in a little bit so you can see this a little bit better. If I go, it's just a shift greater than, shift greater than, shift greater than, shift greater than. That's pretty darn cool, man. That's pretty darn cool. And again, we just use the equation of a circle. So if I'm teaching calculus, there's no reason why I couldn't have used any function whatsoever. I could have rotated a parabola around the x-axis and ended up with something similar. It just wouldn't have been a football shape. So give this a try with your kids. I have used stuff like this with anybody from in my geometry classes to non-AP calculus students. So it's certainly doable. It is certainly doable, but that is that for me. So I'm going to stop sharing my screen, and I'm going to do my best to try to pass the ball to Becky Underwood.
Hey, Steve, got a question about how you change the color.
Yeah. I guess I right-click on the color.
I can send it back if you want.
If you want, if that's okay, is that okay with you?
Yep. There's
Send it back to me.
time, so I can do that.
Send them back. That'd be perfect.
I think I did.
Thanks, Becky. I appreciate that. So to change the color, what, we don't like a blue football? So so I'll do a couple of things. If I go to the View menu, it's probably not the best place to do this. I can hide and show. No, I won't do it that way. What I do is I would go Control Menu on my keypad. But let me change this to a handheld view. And so if I go control menu on the keypad. This is where I can hide and show the boxes, for example, and hide and show the axes. Now, if I click on my shape and I go control menu, this is where the color comes up. And so if I go down to color and then I go to fill color, then I can change it to brown. And now I've got the brown color. I will say one thing about this. I'll let you guys play with this on your own. If I click on the color again and I go back to color, the custom color plot is really pretty cool. And right now it's just a solid surface color, but you can vary the color by height or vary the color by steepness, and then you get this groovy football, man. So that's how you change the color. If you want to learn more about this, I'm going to do a presentation on this at T-Cube, man. So stop in. I think it's on a Saturday.
Hey, Steve, before you pass it back, someone asked, can you animate that?
You mean like this? I can't see the chat window. I guess I could at the chat window. So what I do is on the keyboard, there's a couple of shortcuts. A just automatically rotates it, like if you're too lazy just to grab it and rotate it yourself. A will automatically rotate it. And so, and you could animate the actual surface of revolution happening by adding a slider in there. But again, we'll cover all that stuff at the session at T-Cubed.
And also, if I could just add in real quick, Steve, just to plug Steve's session at T-Cubed. Before I met Steve, I'm okay admitting that parametrics weren't my thing. And I'm not sure that I'm a parametric expert at this point, but I feel a lot more comfortable using parametrics just from what I've learned from Steve. So if the parametrics that he just did made you a little nervous, or you're thinking, oh, you know, my Algebra 2 students could never do that, I think that maybe talking to Steve would help, and that your Algebra 2 students and definitely some other upper level math classes could also use parametrics.
Thanks, guys.
Okay, I think you're back to me. This is Becky Underwood. What I'm going to do is, when I started working on this, I asked my kids what they thought of my students. What do you think of when you think about that big game that's played every year? And I had about half my students say, well, I can't wait for the commercials. So that made me start looking for how could I use commercial data in my classroom. So I actually am doing an activity on Friday with my calculus class that at the end of this I will show you what that is. But for now, I just started it pretty simple so that everybody could kind of be involved. And I have been sick for about 3 weeks, so if you heard me hacking in the background, I tried not to, and if I start coughing, I apologize. That's all I can do. So on mine, what I have found, I was able to research and find the average cost of a 30-second commercial for the big game. And so it's back in 1967 all the way through, so you can see my data here. When I taught like Algebra 1 and we had an integrated math class, we always did fits of data with linear equations, but then we also had to do exponential equations. So that's where I'm going to go today. So what I would ask my students first, and I would send them this data, I would not make them type it in, but you could let them type it in. But I actually sent it with my navigator to my students. What I want you to think about, and I am not looking at the chat window, so I'll have to have somebody else tell me, how can I go about, like with this data, do you notice anything about it as I kind of scroll through what's going on with the data? Is there anything that you actually notice about it that catches your eye? Okay. Oh, here it pops up. I didn't know it did that, so I can see the question. It pops up. It keeps going up. I noticed when I looked at it, it's going up fast and it's increasing. But notice right here, in 2008 to 2009 it increased, but then it dropped a little bit in 2010. Then it grew quite a bit again, and there were a couple of places that it dropped. So when I'm talking to students about that, I would ask them, you know, what happened? Is there something that you know of that might have happened at that time? I'd do the same thing if I use data like world population data or United States population data. What happened during that year? Is it something that you noticed? Okay? So I left a column for you over here. What I make my students do is I would not let them use the calculator to begin with to do a fit on their data. I would make them actually calculate it manually. So I am going to go and plot this data on just a data and statistics page. One of my favorite features, actually on the Nspire, when I first started, I thought, oh, I'll never use that, and I use it constantly. It's one of my favorites. So here is the data with the year on the x-coordinate and the cost on the y-coordinate. When you look at that data, the way it is there, just by the picture, what do you notice here? If you want to put it in the chat window. Looks exponential, growing exponentially. I don't know about your students, but my Algebra 1 students, especially to begin the year, think everything is a line. So everything is linear for my students. So if that's what I had been working on, or even if it wasn't, I say, okay, let's fit a line to it. I'm going to be a little lazy. I've already done a computation, and I'm going to just add that to this window. I'm trying to keep from coughing too awfully much. So I actually like to add it right here. You can also put this same data, and I'll show you later how to put this on your regular old graphs page, because a lot of my students prefer that. But I am going to go with my original data here. It started at 4,000, so that's my coordinate. And then I had computed already just the average rate of change from the first year to the last year that I have at this moment. And so I don't know about your students, but oftentimes my students will pick the first and the last point. And if they do that, I will say, okay, that's good, but what could we do to make it better? And we would mess with that until we got a better fit for that data. However, really, that's not a great fit. So I would say I'm just going to make another data and statistics page, same exact information on here. But if you think it's exponential, that's what we thought, let's do the same thing and graph an exponential function. Again, I already have mine computed, and I will show you in just a little bit something else with my data. Times E, I have already computed a growth, a K-value, my students would call it. 1967, I think it was. So here is a fit that I came up with pretty quickly with that data. So looking at that, my students would say, well, maybe that's the better fit, maybe it's not, maybe the line was better. And then I would definitely, if they didn't, okay, it starts out really great, but what's happening out here? So I'd like to ask you about that. What do you think's going on? Just ignore that data? Okay. We can throw that out and deal with the data up through 2005. Some of my students would want to do that for sure. Economic crisis, I see. What else is going on? Because, and according to what level you teach, because in an Algebra 1 class, I would not go any further with other equations. Exponential and linear is about as far as I get. But if you're teaching Algebra 2, I know Becky Byer teaches Algebra 2, and Becky, what would you ask? What other equations might you ask your students?
My kids would play with the power equations.
So a power equation, it's more quadratic than exponential. That looks right. And we could go and do all of those things. What I wanted to make sure that you would see, though, here's what I like to go do with my students afterwards. I always make them a cubic function. There's all sorts of things. So I'm going to go back here, and now I'm going to make the calculator do the work so that we can find out exactly whether or not linear is a good fit, whether exponential is a good fit, and start talking about that. So I make my students absolutely do things by hand first. I want them to be able to compute, be able to do this without the use of technology, but we verify with the technology. I also teach AP Calculus, so I always think about part of the test is no calculator and part is with a calculator, and so I always make sure they know how to do everything. So let's go. I would have my kids do a regression, and mine all do mx plus b, even though it doesn't make any difference. Well, obviously, that line's better than the one I did, okay? But if I add a calculator page, this is how I do it. There's all sorts of ways. Becky showed a way earlier to get your R-squared value, and my kids would talk about that. I would go look at the R-squared value for, and I'm just going to type linear equation so I remember. That's what this is. That's my R-squared value for that. And I don't know. Yeah, I would tell my students that a 0.86 is not good enough of a fit. However, when I've worked with science teachers, they have always said, ooh, if I could get a fit that good with real data, I would be happy. All right? I'm going to make another page, and let's go do the same exact thing with the exponential and have that and see at least. We all thought it looked better. So if I analyze and put on the regression of an exponential equation, definitely theirs looks different than mine, but it looks good. And so now I am going to go back to that calculator page and get my R-squared value again, because now it deals with the equation I just computed, and it's a 0.972. So obviously, my students could tell me now I can actually say that exponential is better. Okay. We definitely could go add other things to this. We could definitely look at quadratic. So I think whatever level of math that you're teaching, you could find something with this. In pre-calc, we introduce logistic equations, and then in calculus, we do logistic. And I'll find out for sure, because I haven't done this with my students yet. Oh, residual plot. I have that coming here in just a moment. If I go and look at this exponential, wherever I skipped right past it, sorry. So my students would say, it looked exponential to begin with, but then it started to, maybe it's leveling off. So maybe it truly is a logistic function. We could go and mess with that a little bit according to what level we are in. Before I was going to show you, if you have questions or anything to add, if you will do that in the chat window now, and then I was going to show you kind of what I'm going to do in my calculus class, because I didn't think I would have any time left, because I thought Becky and Steve would go longer, but I ended up with all the time, so I can do a little bit more. So any questions, any things that you see that you might do with this, with your students, other than what I've done, besides what you've already added about using quadratic power. Anything else? A piecewise function, you could absolutely start out with, that's a great idea, I hadn't even thought of that. Do a exponential until somewhere in here, and then make some other equation for the rest of it. That would be perfect. I hadn't even thought of exponential. Thanks, or piecewise. Thanks for sharing that. Anything else? All right, I still have a little bit of time. So in my I'm actually doing this on Friday with my calculus class. And we're in the middle of dealing with differential equations. It's a BC calculus class, so we're dealing with logistic and exponential differential equations right now. So what I am doing with my kids, it starts almost identical to what the data that you have, only I added a column for symmetric difference quotient. And If you teach calculus, you know what I'm talking about there. And then I have them, because it does look exponential, actually go in and take a percentage, the symmetric difference quotient with relationship to the cost. And at the bottom down here, if I can get to it without scrolling past it, I actually did a sum or an average of this last column and found actually a growth rate to use for my K value. So this is me working through it. I'm not actually creating it now. But what my students are going to have to do is, looking at this data, they actually have to come up with the differential equation, not the equation of the function, but the differential equation. So that's what I have here, is where they came in and they came up with the differential equation, and we plotted the slope field for that. And then we went ahead and put in the equation. So that was something I've added. What do you do to add, based on these equations? I didn't see that one. Went away.
What's the base for this year's commercial?
Well, for this year's commercial, it's all that I have been able to find is, so far, is a little more than $5 million, but I haven't been able to find exactly how much more.
What is your equation?
What does my equation predict? Okay, so let's go. Well, which one do you want to use? Linear or exponential, or my logistic one? Because we have all sorts. So exponential. So let's go, and I have that where I'm going to ask my students that same thing. I'll go use my equation that I did, because I know I have that stored. I just don't remember what I called it. I think it's F1. So F1 of 2018. 5,999,200. I agree, because I did the power function and quadratic when I was looking at this. They actually do fit a little bit better. If you have tried that, I got up to like about a 98 was the best R squared value I could get. Oh, I'm glad you asked, what do the residuals look like? Because my students are going to have to do that in my calculus class. So there's my logistic somewhere. So and that's what I'm going to make my students look at. On the exponential function, I have the residual plot down below. I'm trying to keep from coughing, I apologize. And you can plot those right together on an Nspire, so that's what I did for that. And I have always taught my students, if there's a pattern to your residuals, that's probably not the best fit. Then my logistic, that was something else they're going to have to do. And here was my logistic residual. And so my students will probably say, I'll have to wait till Friday for sure, but from what we've done in the past, they'll probably say, I think it's a little more logistic because it's not quite as much of a pattern as the other. I don't think it's either, and actually I started researching, and it looks like my data is very similar to like stock data, and it has the same ups and downs, very similar to growth rate if you're looking at growth of stock. So, all right, was there another question? I can't remember. Michael, if you're ready to take over, or if anybody has something else to add, I think I'm good.
Sounds good, Becky.
Oops, I have to figure out where I was. Stop sharing my screen.
Sarah, I agree with you. This is Becky Byer. I was really excited when I did this one because I think with my AP Stat Kids, some of the patterns and residuals are great to do with your students. To talk about lines of best fit. Like I was just sitting here thinking while Becky was playing, I wonder what would happen if you tried to linearize your data, taking some logarithms, if that would fit out.
Well, if I take control back, I actually did that on my, I took my exponential data and I took the ln of the ops function and plotted that, because that's something I teach my students to do as well. And then if it looks linear, then we know that exponential is the correct fit. And it was pretty good, but it wasn't great. And it was kind of interesting. You might pay attention to what your R-squared value is on your exponential fit, and then compare that to your log plot and your residual for your line, and see what you notice about the similarities between those two numbers. Because it's kind of interesting.
I did give you control back, so do you want to go ahead and share your screen?
Okay. I'm sorry, I didn't realize. Maybe. So one of the plots I skipped right past, this was actually what I did is in one of my columns, I took the ln of my, so I did like a semi-log plot and took the ln of my cost data and graphed it. And then here's my R-squared value for my line now. And then somewhere on here, I know I have it, I just don't remember where it is, all these pages. And my R-squared value for my exponential fit. There's that page and that page. Just wanted you to think about, oh, why did that even happen? What's going on? And I'm thinking that it should happen. Is that what you wanted to see?
Oh, you have a question in the window. Does that have a question? You see that question?
I don't have a question. I have a question for you off topic.
You take after AP if they don't go.
Oh, if we offer, we have an AB and a BC calculus, and I do have some students that you said if they don't go on to BC, and we actually have that. Some of my students, we're on an accelerated block, and they actually, some just do not take a math class at all. They just stop. And others, a lot of my students, because I had 4 juniors last year in my AP BC class, and they're actually taking AP statistics this year. Michael, I'm handing it back to you.
Sounds good. Thanks, Becky.
So I can cough.
As we begin to wrap things up tonight, if you do have any last-minute questions that you think of for either of the Beckys or Steve, feel free to get those asked. I know they'll do their best to get those questions answered. I do want to share a few things that are available from our website, education.ti.com. There were a lot of things that were talked about tonight, sort of activities that weren't necessarily pre-made, that both Becky's and Steve had kind of created on their own. But if you're looking for something that's a little more pre-made, if you visit our website and go into the Activities tab, the first 2 choices are 84 Activity Central and Math-Inspired, and those are 2 great places to find more activities that usually contain student notes, teacher notes, and if there's any sort of actual calculator files that go with that, those are usually all housed there for both the TI-84 and the TI-Nspire as well.
Michael, I'm not sure if you muted me or not, but I mean, for the 84 users, most everything that I did tonight, you could also do on the 84, just works a little bit differently because I played with it to make sure I could do both, and so I don't want you to think if you don't have an Inspire, you could not do that activity, because you can.
Thanks so much, Becky. And then just to give more information about our upcoming webinars, if you view under the Professional Development tab and slide down to Free Online Learning, and scroll down, you can view upcoming live webinars as well as our on-demand webinars. So all of our previously recorded webinars are available for you to view at your own pace. Let's click on Live Webinars. You'll see that we currently have a schedule all the way out through the middle of April. You can see the technology that it focuses on, as well as the title. And then if you were to, for instance, click on one of the plus signs, it would give you a little more information about maybe who's presenting, what some of the topics include, and the technology as well. so please feel free to visit our website to learn more about our upcoming webinars. As Steve kind of already started to plug, tonight he's going to be presenting at the T-Cubed International Conference coming up in San Antonio in just a few weeks. And I'm also going to be presenting, I'm pretty sure, both Becky's, are you guys going to be presenting as well?
Yes, we are.
That's great. So it's a really great place to attend some of these really great sessions put on by some really great instructors, as well as just other teachers throughout the United States and across the globe. It's a great place to connect with all those teachers and educators and like-minded people. Like I've been mentioning over the past couple weeks, I think one of my favorite things about the conference is, for instance, let's say I wanted to plug Steve's brain a little more about some of the parametric equations that he was using tonight. We have time at the conference to do that. So if even there wasn't time in Steve's session to do that, I can stalk Steve later and follow Steve around and try and get home more information about parametric equations out of him. But either way, it's just really great to make those connections. I think that's the thing that I found to be most beneficial to me as a teacher. Anyway, we hope that you'll be joining us in a few weeks in San Antonio. And as Becky mentioned earlier, tonight we're giving away to one lucky winner a conference registration for 2 to the conference. And tonight's lucky winner is Zarina Flores. So Zarina, congratulations. We really hope to see you as well as everyone else at the T-Cubed International Conference. When you leave the webinar, a brief survey will automatically appear in your browser. We hope that you'll provide us some feedback as to what went well and what we can do better, and some other things that might be looking for in the future for upcoming webinars. We definitely listen to your feedback, and we really hope you'll share your thoughts. To receive a certificate of attendance, go ahead and click that link in the chat window. Also listed is a link for the documents that were used tonight. In the event that these links don't work for you right this second, have no fear, you'll automatically get a follow-up email. And in that follow-up email, you'll get a link to the recording, a link to the certificate, and a link to the documents. And if you happen to watch this on demand, go ahead and copy that link into your favorite browser to receive your certificate. So thanks so much, Becky Byer, Becky Underwood, and Steve Phelps for joining us tonight and sharing everything you shared. Becky Underwood, we hope you feel better soon. We thank you for persevering and pushing through with a few coughs. So thanks so much, everyone, for joining us tonight, and we really hope to see you back online real soon. Have a great night.
Thanks, everyone.